Alright, hey guys, and welcome to example 9 in the Pyro introduction tutorials. And this one we're going to take a look at the node in the .NET called smoke object. So we're not going to do anything special out here in the sub level. We just have a little sphere, a regular field called temperature and density. Some noise, no velocity really, but yeah, just those two fields. So we can take a look at what we can do with the why the smoke object is essential and what we can do with it. So let's dive into the dops. So in here we have a regular setup. We have a resize container. We have our source volume node that sources the volume. We have located the thing here, the path to the volumes or the fields. And yeah, so no real description here. I'm just going to go over it in this video instead. So the smoke object is essential to our simulation. If we do disconnect this, we're going to realize that we can't simulate anything. And this is because this smoke object right here provides the bounding box and also the division size, which kind of determines at what resolution our volume is being simulated. So let's go over that first. In the properties tab here, we have a couple of things here. Usually want to stay on two-dimensional XY plane, division size by size. In the division size, you can have, here is a very key part of the smoke object. This is where you find how high or low res your simulation is going to be. This is basically how many voxels you're going to be simulating. So this is the size of each voxel. So the explicit size of each voxel. The number of the voxels will be computing by fitting an integer number of voxels by the size into given bounds. So the bounds is basically bounding box. So if you have a 0.2, it will fit the 0.2 value into however big your bounding box is. And the bounding box you can define here. So the bounding box is now 7 by 7 by 7. The division size is now 0.2. And therefore, if you simulate a little bit, this is just a regular smoke simulation, nothing fancy. We can take a look at here, and we can middle mouse click and see that we have 34,000 voxels roughly in our density field. And the density field is 33 by 34 by 31. If we now instead go back to frame 1 and switch this to 0.1, our voxel size or our voxel count is gonna be quite a lot more. Let's take a look. And we can already see that it's more detailed. We can see way more details in this, even though it's not very detailed, but we can see a little bit of it. So if you go here, middle mouse click, we can see that we have 226,000 voxels in the density field. And the density field is now 55 by 71 by 58, which is quite a lot higher resolution, which is one of the key parts of the Pyro or the smoke object here. So those are some of the key features. What we can do as well, we can obviously lower the size of this if you want to narrow it down. Like this, if you want to close it in on this sphere. This will make our simulation a little bit faster. So we can size this here, and then we can transform it by just moving here. If you want to do that, that's totally fine. An issue with this is that we have this node here that is resize dynamically container. So this resize container will actually sample the densities and figure out I need to expand the bounding box now. There's too much density in this voxel, so I need to expand it, which is going to increase the bounding box, which is also going to increase the simulation time. But it's essential to actually get volumes that doesn't collide or intersect with the bounding box, obviously. So if you play it now, it is going to scale it up. It is going to resize it accordingly. But what we could do, obviously, we can switch this off. And now it's just going to simulate statically. And as you can see, it's going to collide with the bounding box. It's actually not going to collide. It's just going to clip it and stop simulating. Another thing you can do, it's a cheap trick, but it works sometimes. If you want to get technical with it, you can scale it up a little bit like this, and you can click here, closed boundaries. This means that the walls of the bounding box will now act as a collider. So the smoke will not just clip and disappear, it will actually collide. And it's a really fast collider. So sometimes you might be able to do this as a ground plane collider or a wall or something like that. And it's faster than actually sample geometry as collider. So let's play it. And we're gonna see that once the smoke reaches the top, it's gonna not disappear. Instead it's gonna collide and go along the edges, just like that. And it's really fast collisions, so it's quite cool if you actually can use it. And under here, close boundaries, you can actually also define where you want to close the boundaries. So let's say I want to close only in the Y+. I'm going to click off all of these, which means that this side, this side, this side, and this side, and this side is not going to collide. Only the Y+ side, which is Y upwards, which means we're still going to collision this one now. But it's going to clip on the sides like that. So it collides on the Y+, but nothing else. I'm going to tick all of these again like that. And then we're going to untick this actually. So that's some cool things you can do in Properties tab. Let's go over the creation. In the creation tab, there's not so much things you can change. Creation frame, for example. Now it's set to a channel operation here. It's the default value. You can delete that by pressing Shift and Control and clicking. And then you can define that I want to start my simulation at frame 15, so let's say. You see, nothing on frame 1. We're gonna sim, and voila. It starts on frame 15. So it starts sourcing any volumes at frame 15. That's a very cheap way or a very easy way of just defining what frame you want to start on. But usually I try to keep it at the first frame. So we're gonna revert defaults, and as you see, it's back. Cool. So there's not so much else you can do here. You can rename the object name, but right now it's called $OS, which means it's gonna be called Pyro, which is the name of the node, because this refers to the operator's name. And it's within the expression. Instancing, I'm not gonna go over now. It's quite cool for making long smoke trails and stuff like this. You can actually instance multiple bounding boxes instead of creating one big bounding box, and it's gonna reduce the sim time significantly, but we're not gonna do that in this tutorial at all. I might do a future tutorial about that, but it's quite cool. And that's it for these tabs up here, to be honest. Down here we have the guides tab. We went over this a little bit in other tutorials. We have a couple of different ways of visualizing our fields. We have the multi-field that we used in an explosion, which can visualize the emission and the smoke, so the density and the temperature and heat. We can visualize our density only, which only visualizes density. We have some sliders here. We can visualize a temperature, which goes like that. It usually visualizes as a 2D plane, just like a heat map. It's quite handy. If we have fuel, which we don't have right now, if we have divergence, we don't have. Burn is when temperature and fuel, when the temperature ignites the fuel. We don't have any burn field here, since we don't have any fuel. The heat, we don't have any heat either, because that's created by the temperature. Velocity, we don't have a velocity either, but we can visualize the velocity with those like velocity strands going from blue to red. Blue being a low velocity and red being a high velocity. Collision, we can visualize any collision areas between objects or between the volume and the object. The source is, yeah, I don't really use that. And sink is also like kind of like a bounding box where the smoke is just deleted. So you can actually define sink objects. You can have a sphere that actually just deletes the volume, that interacts with it, and that will show up as a red volume like this. As you can see, the bounding box shows up as a red volume, and that's because it's kind of like a sink object. More about that later, probably. And then you have all the multi-tabs, all the other tabs for each of these visualizers. I'm gonna go to the multi-field for now. Then we have an initial data. Here we can source a single frame of density, a single frame of temperature, a single frame of fuel, a single frame of velocity, We also have a wind tunnel direction here. So if you put a 5 here, it's gonna have a wind in positive X direction of 5. Let's play that. As you can see, it now has a wind. I'm actually gonna go ahead and turn this resize dynamic node on again. And we can see that it now has some wind. This is not usually the way I want to create my wind for smokes and like volumes, but it can be done. It's a very easy way of doing it. Just define a vector like this. So it's quite cool. Obviously you can do any direction, Y, X, Y, and Z, anything you want. These I don't really use too much. Rest fields, we're not gonna talk about rest fields now either. Yeah, that's it. Then fields, it's just if you want to delete a field that you don't use, that is actually present, then you can do that by here, by unchecking it. But I don't really do that too often, to be honest. And in masks, I don't really use this either. You can switch off the masks of things if you feel like that's eating up your memory or something like that. But usually it's not that important. So yeah, that's it. Actually, yeah, you can actually visualize this as a 2D dimensional plane as well. I didn't mention that. But if you don't want to visualize it as a 3D smoke, you can do it as a 2D like this. It's quite cool. You're gonna see like a cut through of it, which can be kind of interesting. Gives like really like interesting shapes like this, which can be kind of cool. You can obviously visualize it from any direction. So now it's YZ plane. Like that. Yeah. You get it. You get the gist. Anyway, that's all for the smoke object. Hopefully that cleared some things up. Main takeaway is the division size, the size of the container, our bounding box, close boundaries, and kind of guides to work, and a little bit like that. So go ahead and play around with a smoke object and see what you can do with that. And just keep in mind that it's essential for Pyro simulations. And it always goes into the gray tab, the first one in the Pyro solver, called object. Anyway, thank you guys for watching, and I'll see you guys in the next example. Bye.